friction.
Yes, and the formula for friction?
The mu s times normal force.
Yes. So, first thing we need to do is establish, is it going to slide? So, to establish whether it's going to slide or not, let's assume maximum static. Are we going to overcome that? So this F here, we're going to replace with mu s y. So I have y from the first equation is equal to mg cosine theta. And in the second equation, I have mg sine theta minus mu s y is equal to ma. And now we solve. I have a formula for y right here, so I'm just going to take that, plug that into y. I get mg sine theta minus mu s, and that is just getting worse and worse. So let's see if we can try that again. Mg sine theta minus mu s mg cosine theta equals ma. And lo and behold, what factor do we have common to every term? And thus the mass is irrelevant because we can cancel it out. Technically divide both sides by the mass. And so I'm left with the formula for acceleration of A equals g sine theta minus mu s g cosine theta. And so let's put this on Earth 2.
So is mu s only for y-axis and the mu k is for x-axis?
No, no, mu s is static. That is something that's not going to slide.
Okay.
UK is, we know it's sliding.
So like if we had like a y on the I hat, then that means the mu k.
No, we still have to establish whether it's going to move or not.
But since that so like if we had it on the I hat, but we established it's gonna move down, we're gonna use the mu k for.
Yeah.
Okay.
Once we know it's going to slide, we would use mu k.
Okay.
Earth 2. So G 10 meters per second squared. So I have 10 times the sine of 30 degrees, which is 0.5, minus 0.8 times 10 times the cosine, which is 0.866, I believe. And you work through it, and you end up with
negative 1.928.
units. Say it again.
Negative 1.28 acceleration, or meters per second? Squared.
Yes,
Okay.
it should be an acceleration. The sine of that is unitless, that's unitless, that's unitless. G is the only thing that has any units, and that's in meters per second squared. Cool. All right, so what is the acceleration of the box? It is not. It is not. Unless you want to get into a philosophical argument.
Because the answer came out as negative, it means that we now have to solve for MK.
Nope.
It's
It's
not
not gonna move.
It's not moving. So
Therefore, the acceleration is
0 meters per second squared.
yeah. If this is truly the acceleration, remember we said the positive direction was down the ramp. If it is accelerating in a negative direction, that means I have the ramp here, put the box on it, suddenly it starts going this way. Because it's starting at rest, acceleration is negative, which means my velocity will have a negative change.
which means I'm gonna go from 0 to a negative number, which means the box will go up the ramp, which just physically does not happen. So, also note that this right here is that right there is the maximum static friction. We did not overcome it. So we can do, questions to there before I do my follow-up. Ritika?
So, for acceleration due to gravity, when we substitute mg, should we do -10 because it's downward?
We've already taken the direction into account here. So we're not gonna add another negative. G itself is a positive number, unless you have some sort of anti-gravity field.
It is, but when we establish directions,
W equals mg regardless of what you're choosing as positive or negative.
How do we always use static instead of kinetic?
We had to establish does it slide or not. We can't use, if you just jumped immediately to, oh, I know it's gonna slide, then you might get lucky, or you might completely miss the point of the fact that it's not going to slide at all.
Also, we have to go through static first and then we go to kinetic. We can't-
Unless the problem states that it's going to slide, you don't know.
So that's a positive, we go instantly to kinetic.
Yes,
Okay.
Okay.
And then, how did you get the y mu static again? I forgot how you, I don't think I understand that part.
how we got
So
y
like,
times mu static.
So how did you like substitute the friction with mu s y?
Okay, the formula for friction, for kinetic friction, the formula for kinetic friction, so we know it's sliding, is that coefficient of kinetic friction times the number of friction.
Okay.
For static friction, the maximum static is mu sy. Or if we write it more generically, Fs is less than or equal to the maximum. Yes, Barbara?
Can you just explain a little bit more why 10 isn't negative?
When you are,
we usually do -9. I know
that's because in the problem, when we're doing projectile motion, and we're setting up what we know,
Right.
that's the vector acceleration that we're trying to find right there.
Uh-huh.
In which case, the vector acceleration has a direction. In this particular case here, G itself, this formula right here, these are scalars. Even though weight could be a vector, there's no vector symbol over anything in this formula. These are scalars, so these are all positive numbers. It'd be similar, and this is one of those cases where everyday life sort of matches that. You know, if someone asks you your weight, you don't go, well, in my case, 220 pounds downwards. So G is a positive number. The acceleration due to gravity is a positive number.
When do we make it negative then?
You make it negative when you've established up is positive and you're trying to find the vector acceleration.
What are we finding here?
Well, I know that my acceleration is down the ramp.
Okay,
It has a scalar value of A. The
okay.
direction is down the ramp. In my formula here, let's see, can I do this in a more convoluted way? I think so. Give me a second here. Let's see, so. No, all right, so this formula comes, I assume you have a question?
Yeah, my question is, so this entire time, when you've been writing the lowercase a, and you haven't, sometimes you haven't been putting the vector symbol over it, that's because it's a scalar. So
Right,
I have.
unless I made a
no-
mistake, yes.
Okay.
This whole thing combined is a vector. Because a vector has a magnitude and a direction. That's the magnitude, that's the direction. All right, I'm gonna hopefully kill a couple birds with however many stones it takes. So I want that over there. All right, so if I plug into F equals ma, it's the sum of all the forces. So it is equal to the weight plus the normal force plus the friction is equal to mass times acceleration. That. All right, I just add the forces together. I have vector symbols in there. This is not particularly solvable as is. I know if I bring in my I hats and J hats, it's established over there, I still have weight. I'll bring that in just a second. Plus the magnitude times J hat plus the magnitude times negative I hat. The magnitude is F, the direction is negative I hat.
Right.
Is equal to mass times acceleration, and I know acceleration is down the ramp, so that's A times I hat. My weight is not I hat or J hat, it's some combination, so I break it up. So I know this is W sine theta I hat plus W cosine theta negative J hat plus big Y J hat minus F I hat is equal to M A I hat. This is taking it through a slightly different process to get to the exact same place where we were. I have my total force is equal to mass times acceleration. I start narrowing it down some. So now I have this equation here where I have a bunch of I hats and a bunch of J hats. They need to balance out. In other words, the I hats on the left-hand side have to equal the I hat terms on the right-hand side. The J hat terms on the left-hand side have to equal the J hat terms on the right-hand side. So if I look at my I hat terms, I know that W sine theta I hat minus F I hat is equal to M A I hat. They are all in the same direction. Therefore, if I factor the I hat out over there, let's go ahead and throw that intermediate step in. W sine theta minus F I hat equals M A I hat. Well, I hat's going to equal I hat. The coefficient of this I hat has to equal the coefficient of that I hat. And so we're left with W sine theta minus F equals M and A, which is what we got before. Looking at the J hat versions, I have negative W cosine theta J hat plus Y J hat is equal to, well, I don't have any over here, so 0 J hat. Factor the J hat out, and again, the coefficients would have to be the same, so I get Y minus W cosine theta, it's got to be equal to 0, which is the other equation that we had. All right, next step, independent equations. Regardless of anything else going on here, I can come up with a very simple case to figure out what the formula for weight is that is independent of any of this. I know that if I have an object in free fall, so it is just falling straight down, I know that the force acting on it is its weight. There is no air resistance. Therefore, I can make up positive or down positive. So if I make up positive, this becomes negative, and let's go make it a positive J hat. Negative W J hat is equal to mass times acceleration. I know the acceleration is going to be downwards. And we'll label that A. So this becomes negative M A J hat. The negatives cancel out, and I'm left with, well, A, for something that's in free fall, where the only forces are the force due to gravity, this is equal to the acceleration due to gravity, which is lowercase g, a positive number. So I'd have W J hat is equal to M G J hat. The coefficients have to be equal to each other. regardless, if I made if I made down positive, then those would be positive numbers, and I'd still end up in the exact same spot. But the coefficient here, that scalar, has got to be equal to that scalar. I don't know if that helped or not. A couple of subtle nods.
It helped. I just don't get when it's supposed to be can you do one where it's negative? Like, I feel like we've done problems and I wrote. I don't know.
In the, all right, let's do one where,
Like when we launched the notes from 828. When we launched something at a 37-degree angle, we put negative 9.8.
because we were writing in the acceleration, weren't using the formula for weight.
So when you use weight, it's just a matter of like the direction because of I hat and J hat.
When I am writing down the magnitude of the weight, I'm using the magnitude of the acceleration due to gravity. The direction of the weight has already been taken into account. That's when we broke this up, we took the direction of weight already into account. So now I'm just trying to figure out a formula for weight that is independent. This right here, that's in essence where we get the formula for weight. I feel like I'm repeating myself, so
I get it. I get it.
okay.
I'm writing it down, don't worry.
All right. Other questions on this? Let's take it one step further. What is the static friction acting on the mass?
0.8.
That's a coefficient. I'm looking for a force. Yes, please don't confuse friction with the coefficient of friction. The coefficient is dependent upon the two materials that are touching each other.
Is it normal force again?
Well, we solved for friction as max already, friction
Yep.
static max, so is that what you're asking?
Nope. We've established that we are not overcoming the static friction.
So then we have to figure out what is that.
Yes, what exactly is the static friction?
It's 6.93. It's 6.93.
Is that when you multiply this together, you get 6.93?
Yeah.
It is not. That's the maximum static. Actually, times the mass would be the maximum static. Let's give it a mass of 1 kilogram, just so we can come up with an answer here. If the mass is 1 kilogram, what is the what is the static friction? Not maximum static, but the maximum friction. That's the maximum. We have not overcome that.
5.28.
Oh, we have to plug that number back into the max and then leave MS as nothing and plug in Y and solve for it? No? Kind of?
No, but you almost said the right thing.
Okay. Good.
What are we plugging back into that equation?
The math.
Ooh. What is the actual acceleration of the mass?
0.
Yes,
That's what we put.
if you plug 0 in for here, solve for the friction. We established that it's not sliding, so it is static friction. The maximum static is just gonna be equal to that. Because the static friction is going to match up until you get to that breaking point. We never got to the breaking point, so the static friction is just gonna match. So it'll end up being 5 newtons, if the mass is 1 kilogram.
So friction will be equal to mg times sine theta.
Yes, because once we establish acceleration is 0, and it's not moving, then these two have to balance each other out.
So we figured out the acceleration is 0 because we found our numbers negative in the when we solve for it. So when ma is equal to 0, so friction, if friction is 0.8, then mg sine theta should be 0.8 as well. Is that what you're
Sorry,
saying?
ask that again, sorry.
So since that our answer is negative 1.928 and it's a negative number, it means that acceleration is 0. So friction must equal mass times gravitation by acceleration. I forgot how to say it, by sine theta. So if our friction is 0.8, then the sine theta should be 0.8 as well. Is that what you're saying?
No,
Oh,
what I'm saying is, once we establish that the acceleration is 0.
yeah.
If acceleration is 0, then the right-hand side of this is 0.
Mm-hmm.
My static friction here, therefore this minus my static friction is equal to 0.
Yeah.
Therefore my static friction equals this.
So the answer is just static friction.
The answer is whatever mg sine theta is,
Which is 5
which is 5 newtons.
kilogram.
Too many birds. Just kilogram meter per second squared. Latika,
So if we did it this way, that would be the maximum static friction.
yes,
And that is just the friction right now.
yes.
Because the acceleration is 0. Or it's not moving.
Correct.